This is the last example for 10.1. We're going to do one more where we're finding the derivative using the derivative formula, limit as h approaches 0 of the difference quotient. So again, first thing that I would suggest doing is establishing an f of x plus h. That'll just make your whole process a little bit easier if you do that. So with this one, it's just putting in x plus h where there was x down here, meaning that we'll have 1 over x plus h minus 2. Okay, so we've got our 2 established now. Let's find the derivative. F prime of x equals, now we got to start with something that it's very easy to forget, and that is this limit stamp. The limit as h approaches 0. And now I put in all this stuff into the fraction. We have a complex fraction. So first of all, f of x plus h, so that is 1 over x plus h minus 2 minus this other fraction that represents f of x. So that's over x minus 2, all of this over h. Now, at first glance here, this one appears a lot harder to work with because it's a bunch of fractions. So we have to figure out a way to get rid of those fractions, and the best way to do that is by combining these up on top and getting common denominators. Now I'm going to have to rewrite this whole thing to get with the common denominators here, but we've got x plus h minus 2 here, we've got x minus 2 here. We really just have to multiply by the other one on each side. So next step. There's going to be a lot of steps in this one, a few more than the last. Start with that one. I'm going to leave myself a little bit of room on each side of these fractions. So I'm going to leave myself a little bit of room on the left-hand side here. And then I'm going to leave myself a little room on the right-hand side over here. So on the left-hand side, the part that I'm missing is x minus 2. So I'll multiply by that, top and bottom. And on this side, the part that I'm missing is x plus h minus 2. So notice what that's going to mean about these fractions is that they will have common denominators. And so now I want to combine those together. I would avoid the temptation to FOIL these. You might want to FOIL them, but I think it's going to work out easier in the end if we just leave them in factored form. But up on top here, noticing that these are each just multiplied by 1. So really, we're just going to combine things. Now we do need to be a little bit careful how we combine. On the top here, we have x minus x, so those can cancel out. Then we have negative 2 minus negative 2, so that's really plus, and so those are going to cancel out as well. So get rid of those, and that leaves up on top just 1 minus h, really. So it's just going to be that as we go forward in this problem. Actually, you know what? No, it's not going to be the 1. Sorry, that's incorrect. It's going to be x minus 2, and we cancel both those out, so it's just going to be minus h. So as we go to the next step, we are going to have just h, negative h on the top. It is negative because we are subtracting those fractions. I'll put that in green. Over all of this stuff, x minus 2, x plus h minus 2, over h. All right, so once we get to this point, then we're, again, just working with fractions. We're just trying to get things simplified here as much as possible. But think about this as a complex fraction where this is that whole fraction on top divided by h over 1. So if it's divided by h over 1, it's the same thing as being multiplied by 1 over h. So I'm going to keep going here with this line and keep that limit stamp in there. I might need another piece of paper in just a second. But now I will have my fraction negative h over x minus 2, x plus h minus 2. And I'm going to multiply it by 1 over h. That was from the bottom. And so the nice thing about this is now I can cancel out an h on top and h on the bottom. There is still going to be a negative 1 up there, but that goes in on the next line. And got to keep my limit there. I'm almost done using this limit notation. Almost ready to get rid of that. But we have then negative 1 over x minus 2 and x plus h minus 2. All right, from here, we can finally substitute 0 for h because it's no longer the only thing in the denominator of this fraction. If we put 0 in there, then what we get is just negative 1 over x minus 2 times x minus 2, so that just becomes x minus 2 squared. So this is our derivative. It's f prime of x equals this. And so now our goal in this case was to find the slope when x is equal to 4. So I'm going to put this off to the side now. This will be the last thing that we have to deal with in this problem. And so we have, like I said, f prime of x is equal to negative 1 over x minus 2 squared. And so we want to find it at x equals 4. So f prime of 4 equals negative 1 over 4 minus 2 squared, which is equal to negative 1 over 2 squared. So negative 1/4 is going to be our final slope, our derivative, at the point x equals 4 in this case.